Nuclear power is the future of American energy. 19% of America's electricity comes from nuclear power. Not only is this energy reliable and vast, it's clean and will reduce the impacts of climate change.
Arguably, we need to change the status quo of the nuclear power industry in America. Instead of traditional light water reactors, the most efficient future lies in molten salt reactors, which use salt heated to the point of fluidity as a primary coolant. Thus, it is less likely for disastrous meltdowns to occur, unlike light water reactors.
But where will you find the funding for research, testing, and development? How are you going to build up an infrastructure and supply chain when there's nothing that already exists?
There is opportunity for policy change in the future, for innovative, safer, and cost-effective nuclear power projects. It may be expensive at the start, but we will see a return on investment. The time to switch to new is now. How are you planning to address the various negative impacts of your plan?
Well, although accidents such as Chernobyl and Fukushima have hurt people before, improved safety protocols, strict regulation, and new technology for light water reactors make the likelihood of another catastrophe extremely low.
You misunderstood my question. I was referring to the environmental impacts of the traditional nuclear energy.
Well, nuclear power created from light water reactors have a lower impact on the environment than using fossil fuels such as coal and oil. However, are you aware that salt reactors have many unaddressed issues?
Of course, new technologies will always have their issues, but however, these can be addressed with more research and development.
Hello, here's the science behind nuclear reactions. 1. Nuclear decay. Nuclear decay occurs when the nucleus of an atom is unstable and emits energy through radiation, such as alpha, beta, or gamma. Some of these radiations, called ionizing radiation, are capable of knocking electrons off of atoms, which is harmful to any life form with DNA. In all radiations except gamma, the nucleus ends up changing into one or more different elements or isotopes that have more stable nuclei. 2. Nuclear fission. What these two have been talking about. What happens here is that the neutron gets smashed into a larger atom, making it increasingly unstable. Thus, it splits into a lighter element and releases both energy and neutrons in the process. 3. Nuclear fusion, where lighter nuclei combines together to form a heavier nuclei, and tremendous amounts of energy is released in the process. This could be the solution to the world's energy issue, but takes significant amount of energy to cause this process to occur. Thus, it has been difficult to attain a net power gain from using fusion.